Hello, and welcome to our presentation. In this presentation, we would like to give a short overview on our proposed approach for single-image human proxemic estimation for visual social distancing, a work that has been done in collaboration of Italian Institute of Technology and University of Genova. We are indeed going through a difficult time where the shadow of a life-threatening virus is on our daily life. In this situation, social distancing proved to be an effective way of protecting ourselves and the others. In this work, we propose a simple yet effective pipeline that can be easily deployed on top of the pre-existing video surveillance settings for detection of social distancing violations. This presentation covers the main steps in our proposed method, as well as the experimental design and the obtained results. To measure the distance between detected people in the scene, a conversion from the image-level pixel scale to the word-level meter scale is required. In our proposal, we opt for approximating the meter scale from the subject of interest in this study, which is the human body. This approximation became possible relying on physiological studies which suggest that the average body height is about 170 centimeters and it only varies slightly among different races. Considering the common human body proportions, the average length of human body parts, such as arm, leg, or torso, can also be extracted. We relied on this information to infer the meter-level metric from an image. Given the selected metric inference, a safe space area around each detected person in the scene can be drawn. However, for all the detected people, their circles must fall approximately at the center of their body and on a common plane among all of them. We opt for using ground plane as the most common plane for all the detected people in the scene and computed the average position of feet in horizontal axis to determine the ground plane position. The central position of feet, or if both feet are not detected, the average position of head, neck, and torso are used to determine the center of body in the image. The intersection of these two axes determines the center of the safe circular space to be drawn on the ground. And the same procedure is repeated for all the valid human body detections in the scene. Based on a reasonable assumption, we observed that people often appear upright in the scene. This observation enabled us simplifying the camera extrinsic estimation to only two main factors, the tilt angle and the camera height. Under this assumption, horizontal line will appear horizontal in the image plane. Therefore, a rectangular area on the ground plane at bird's eye view will appear as a trapezoid in the image plane. This projection can be determined with only two ratios and can be used to estimate the homography matrix. We ask the human operators to rely on their visual instinct to decide the best ratios by visualizing the safe circular space per person as an ellipse on the image plane using the two ratios. For evaluating our proposed method, we adapted three public datasets and provided ground truth for social distancing evaluation purposes. The details regarding these datasets can be found on the right of the screen. For evaluation, we treated the problem as a binary classification, where the question is whether the social distancing violation in the ground truth has been detected correctly by the proposed algorithm or not. In this table, it can be seen that the human selection of ratios relying on their visual instinct performs comparably with grid searching over the range of possible ratios. We also compared our proposal against two state-of-the-art models, and as can be seen in the table, our algorithm outperformed those over all the datasets. In an ablation experiment, we have studied the importance of the choice of body parts to be used as the metric inference. As it can be seen, torso outperforms other body parts and also the usage of the mere bounding boxes. More results and discussion on this study is given in the paper and the supplementary materials. For more questions, discussion, or comments, please do not hesitate to contact us or create an issue in our GitHub repository.